Hello everyone and welcome to the Battery Show 2025. My name is Danilo and today I will take you on a guided tour here at our stand, Marposs. So, if you couldn't make it to the show in person, don't worry, we have created this virtual experience just for you. In the next few minutes, we will meet our industry managers and get exclusive insights into our latest innovations. Ready? Let's get started. I'd like to start with a solution that I know particularly well, because actually I am the product manager behind it. This machine here is called Unisensor, and it has been designed to measure the basis weight of film, foils and coated layers. In order to achieve this, we use ultrasound, a completely radiation-free technology that works especially well for this kind of products. From the left to the right, we have copper, aluminum and the battery separator. Currently, our Unisense is scanning across all these kind of materials. The calibration is performed under this master set here. And this whole system is very important for your battery production line, because even small variations in coating can lead to big differences in your battery performances. Unisense can help you catch those differences in real time. But now I want to show you something very interesting. Come with me. So here we are with Silvio, our export sales manager for the ultrasound basis weight system. Hello Silvio.
Hello Danilo.
So what do we have here? I see a very big machine in front of us.
Yes, this is the machine that we have in our test center in Bentivoglio, Bologna. And this simulates an electrode manufacturing line. Here we have our Unisense system to measure the weight of the electrodes during the production. As you can see, we can scan all the products from left to right. And then on the same test line, we also can show our Unisense system for the thickness measurement of the electrodes.
Ah, this is done using the
confocal sensor. This is
sensor.
We use for the weight measurement ultrasound, and for the thickness we use confocal sensor.
So basically this is a complete system able to measure both basis weight and the thickness using different technologies, correct?
Correct, yes. And also we can visualize the defects on the electrodes.
Thank you, Silvio. Now let's move to the slitting phase, one of the most important parts of the battery manufacturing process. Here we are with Franco Stangelini, our EV industry manager.
Ciao Danilo.
Hello Franco.
How are you?
Everything is good, thank you. So what do we have here? I see some blades and some sensors, correct?
Yeah, correct. This is just a demo bench to present one of our new sensors recently developed to solve a specific problem typical of one of the most critical operations in the production of the electrodes. We are talking of the slitting operation, so just a few words about the process. Starting from a big mother roll that's produced of the electrode, it's necessary to cut in the slitting process in smaller rolls that will be used for the manufacturing of the battery. Exactly.
So the same roll I check with my ultrasound basis weight measurement, correct?
Yes, in a previous operation. Here we are in a later part of the process. Before we start to make the assembly of the battery cell, we need to cut at a precise size of the electrode, that will be used in the cell. One of the critical operations is this slitting that is very frequently done with a mechanical blade, a rotating blade.
Like this one we see here?
Like this one. This is just to demonstrate the typical part of the process. It's fake, don't worry, you do not risk to cut. The reason why it is frequently used a mechanical cutting is because of the capability to produce a very clean cut with no contamination of the remaining part of the electrode.
Okay.
One limit of the process is that the blade is touching the film, and as a consequence is wearing out, is progressively wearing, and this will in some way risk to generate metallic bars or other defects in
like
the
one
cutting edge.
we see here.
Exactly. This is extremely critical, because the risk is not the defect or on the blade. The risk for the battery is the metallic bar on the edge, because this could in some way penetrate the separator and generate later the short circuit. Exactly.
That's very bad. We don't want this to happen.
The best way would be to check the quality of the edge on the film, but this to be done in line would be extremely expensive. Several companies are taking samples and checking the samples from the
Manually.
production manually under the microscope. And the problem is that as soon as they realize there is a presence of a defect of a bar, they have to reject the complete batch produced till that moment from the last checking. With this new solution, it's possible to have a continuous runtime check of the quality of the cutting edge of the blade. Because this is a line sensor, an optical line sensor, that is continuously checking with an array of photodiodes the quality and the wear, the progressive wear of the blade.
That's very interesting. It's only light technology.
It's just light. It's just light. Everything is elaborated inside the sensor, so there is no optical fiber that is connecting
It's
the
not like
sensor.
a confocal.
It's not a confocal. Of course, optical fiber is used, but this is definitely much stronger because this is just a digital signal. Everything is elaborated, collected, elaborated inside the sensor, and later sent to the controller that can connect up to sensor and check at the very high frequency up to 100 kilohertz the quality, the presence of defects, and also the progressive wear of the cutting blade. And in this way, you can send directly alarms to the machine to highlight when is the moment to remove the blade, replace it with a new one.
Thank you a lot, Franco. And now let's move on the corner here because I want to show you something related to our leak test. Okay, so here we are with Michael. Hello, Michael.
Danilo, hi. Nice to have you on the show.
So Michael is our EV industry manager for the German market. What do we have here?
This is a crucial part of testing for sealed battery cells, Danilo.
Oh, okay.
This machine is a semi-automatic machine that is doing leak testing for sealed batteries. So, talking about cylindrical cells, prismatic cells, even button cells or pouch cells, I mean, all of them can be tested in this station.
So how does a leak test works?
Well, in the end, you know, for safety reasons, of course, the solvent or electrolyte should not leak out of a battery.
Ah, yes.
Means for us how to prove that it's not going to happen. We are testing directly the electrolyte and solvent leakage. That means we're putting the cells into a vacuum chamber, evacuate it, and then directly sniff with a mass spectrometer for
The
leakage.
presence of any leakage.
Oh, yeah, of
That's
solvent.
very interesting.
Yeah.
Oh, wow. And what do we see here on the screen?
So on the screen, we see, of course, the cycle where we evacuate the vacuum chamber and the reaction of the mass spectrometer to a solvent that might be in the vacuum chamber. Or better said, not.
Michael, thank you again for your help. And now I want to show you one last machine that we will find right here. Come with me. And here we are with Marco Azzolini, our battery test specialist. Hello, Marco.
Hello, Danilo.
So, what do we have here? I see a very big machine with a lot of modules called Best Flex and one Best Ref. What do we have here?
So we have a station for electrical and software testing on battery packs, especially in the end of line. What we did is concentrate all the components inside this rack, reducing the footprint. And we put all the components inside these modules.
So each one of these modules does a specific kind of test, correct?
Yes, specific kind of test. Like
Let's make some example. Like
some
I
example,
see here, low
like
voltage.
low voltage is to power on the battery pack. Vehicle replica is to make the simulation of the vehicle, to communicate with the battery. ACI R100, Y capacity for the isolation and capacity measurement of the battery pack.
So everything is managed through our software. I have seen here that we have also artificial intelligence. I am a very big fan of this. So you
Yes.
can ask the system some insight about how to work on the machinery, correct?
Yes, exactly. So if you have any problems before going and look in the electrical scheme and so on, and losing time, you can just ask to our assistant what is going on, and it will answer to you with a quicker response and a reference to exactly the page of the manual.
No one wants to read the manual anyway.
Yeah, exactly. That's the main problem.
Okay, understood. So, what can you tell us about this best ref here? I think that in order for us to do this kind of test, we need some sort of reference, correct?
Yes, exactly. So this best ref, it's a trolley. It can be moved all around the plant. It's on the wheel. We have some components inside the modules that simulate the nominal value of the measure that we have to do. And we use this connecting it, the specific module to the best flex and making the repeatability measure on this reference.
So this is like a collection of master.
It's a collection of master, exactly. Yeah.
Understood. So why it is called flex?
Flex because it's flexibility, as we said before, of the module. In case of any problems, the customer maintenance can really quick change the modules and go on with.
They can swap them out. We can make replacements or
replacements or integrate a new test also. So this reduces drastically the downtime in production. Another flexibility is about the software. In that case, the customer with a really short training is able to make changes in the software, also in the test sequence and parameters. You can see here the software is a visual programming, so the customer can just really simple drag and drop the nodes and configure them for integrate new checks, new tests, and so on.
That's very interesting.
Yeah.
Marco, thank you a lot for your time. Our virtual guided tour is finished for today. If you want to discover more about Marposs products, please click the link down below and visit our website. Thank you for tuning in and see you on the next fair.